Hi guys. So we are going to discuss experiment number 5, which is the hydrolysis of salt. So the objectives of the experiment number 5, hydrolysis of salt, is first is to identify whether a salt solution or aqueous salt solution is basic, acidic, or neutral depending on the molecular formula. The second one is to identify its pH using a pH indicator as well as pH meter. And then the third one is to explain the chemical behavior of salt in water and then identify its net ionic equation involved in the hydrolysis. But first, or this is the pH. Okay. So, ang ating i-discuss ngayon is in this experiment, we are going first to define salt. Okay? So, salt particularly is an ionic compound. It is an ionic compound. So, we learned in our chemistry that an ionic compound is a combination of a metal and a non-metal. So, pag may nakita kayong metal and non-metal, combination of a metal and non-metal, then that is an ionic compound. And salt is one of those ionic compound. And salt, being a salt, is a strong electrolyte. When we are talking about strong electrolyte, one of the primary characteristics of strong electrolytes, or SE, is it can hydrolyze in water, or it can dissociate, have a complete or 100% dissociation, forming what we call as ions in aqueous solution. For example, so if we have a salt which is a strong electrolyte combined in water, then it can dissociate, it can dissociate or it can ionize in water, forming ions. For example, we have here NaCl, which is a table salt. So in NaCl, when it is put in a aqueous solution, then it can dissociate into ions, forming sodium ion and then chlorine ion. So that is one of the characteristic of a strong electrolyte, which is one also of the main characteristics of salt. Okay. So a salt in an aqueous solution can be identified whether it is an acidic, basic, or neutral in that solution depending on the interactions of these ions in the water. For example, if the ion here reacts with water and form, for example, hydroxide, then the solution is basic. If the ion interact with water and forms hydronium, then the solution is acidic. So that is one of the primary ways in order to identify whether a certain salt can produce a basic, acidic, or a neutral solution. Okay. So one of our objectives is to identify the acidity, basicity, and then the neutrality of a certain salt depending on its molecular formula. Ang alkalinity kasi, acidity, and then neutrality of a certain salt depends on the strength of the acid, and then the base that comprise it. Kasi in a neutralization reaction, acid plus base is equal to salt. And then, the acidity, alkalinity, and the neutrality of the salt depends on the strength of the acid and the base that wherein the salt is derived. Anong ibig sabihin nun? Halimbawa, you have a strong acid. A strong acid plus a strong base. So let's identify its SA and SB. A strong acid and a strong base will form a salt wherein its ions cannot hydrolyze the water. Ang ions ng salt na to cannot hydrolyze the water, making the solution neutral. That's why a salt derived from a strong acid and a strong base is a neutral salt with a pH of equal to 7. Gets? Next, second one. The salt of a strong acid plus a weak base will form a salt wherein the ions or wherein the salt releases cations. Wherein the salt releases cations coming from the conjugate base, coming from the conjugate acid of the weak base. Coming from the conjugate acid of the weak base. Ang salt ng strong acid, ang strong base, it will form a salt that releases cations. That releases cations coming from the conjugate acid of the weak base. So, ibig sabihin, pag nag-release siya ng cation, ang resulting solution natin is magiging acidic. Resulting solution natin is magiging acidic with a pH of less than 7. Tandaan nyo lang, kung sino sa kanila yung stronger, ibig sabihin, yun yung susundin ng pH ng salt na ma-form. Ang strong dito is yung acid, that's why ang salt na ma-form niya is acidic. Katulad din ng sa base. Ang salt of a strong base plus a weak acid is equal to salt, it will form a salt that releases an ion. An ion naman yung ma-form nito. It releases an ion coming from the conjugate base of the weak acid. Ang ion na ito ay nanggaling dito sa conjugate base ng weak acid, forming a solution which is basic with a pH of greater than 7. Ang stronger dito is si base, ang weaker dito is si acid. That's why yung ma-form niyang salt is basic kasi stronger si base. Pero ang ganitong scenario is for stronger acid plus stronger acid. A stronger acid plus stronger base, stronger acid plus weaker base, stronger base plus weaker acid lang. Pero pag sinabi kasi natin na, for example, a combination of a weaker acid plus a weaker base, yes, they can create ion and an ion. Ang salt nila ay magre-release ng an ion and cation. Pero yung pH ng solution is nakadepende pa rin dun sa individual strength ng anion at cation. Kaya kung meron kayong salt na derived coming from a weak acid and a weak base, hindi mo siya agad-agad masasabi kung ano yung pH niya kasi nga yung pH niya is nakadepende sa strength nito. Hindi katulad nung kanina na agad-agad masasabi mo na kung ano yung pH na magiging aqueous solution niya. Yung aqueous solution niya. So in this matter, so alam na natin kung paano natin siya ma-identify, kung paano ma-identify kung whether acidic ba siya, basic ba siya, or magiging neutral yung solution. Halimbawa, paano nga ba 'yon? Halimbawa, so para natin pala ma-identify siya, syempre dapat alamin muna natin kung ano yung mga list ng strong acids and then strong bases, 'di ba? Strong acids and strong bases. So in a strong acid, meron akong mnemonics na natatandaan ko pa nung grade 12. Sabi ng teacher ko, ang mnemonics niya is high, brother, clear, so close, no. So we have high, brother, clear, so close, no. So dadagdagan mo lang siya ng H dito. H2 kasi 'di ba ang charge ng sulfate is -2. H lang kasi ang charge ng chlorate is -1 and H lang dito. Yan. So this is the list of strong acids. High, brother, clear, so close, no. High, brother, clear, so close, no. Okay. So, ang list naman ng strong bases natin is likana, kaasarba. Likana, kasarba. Likana, kasarba. Diba? Likana, kasarba is strong bases. So, ang likana, kasarba. So, sa strong bases, ang dinadagdag natin dito is hydroxide. Dito, ang hinahidagdag natin is proton or the hydrogen ion. So, LiOH, KOH, NaOH, NaOH2, SrOH2, and BaOH2. Ito, may 2 sila kasi nga they belong in group 2, 'di ba? So they belong in group 2 at may charge sila na positive 2. Kaya, crisscross, ang 2, malilipat na dito yung 2. Okay? So, these are the list of strong acids and strong bases. So, we have, hi, brother Claire, so close, no? And we have, li ka na kasarba. Li ka na kasarba. Okay. Li ka na kasarba. So, for example, we have here a salt. For example, we have here a salt. Ang salt natin is NaCl. So, NaCl is a salt. That's why it can dissociate in water, forming a Na ion or sodium ion and chlorine ion. Na ion and chlorine ion. So, this salt, ang salt na to, masasabi natin na nanggaling siya from NaOH at from HCl. Nanggaling siya sa NaOH at HCl. Paano ko nasabi yon? Kasi ang Na, di ba ang Na is may charge na positive, ang OH is may charge na negative. That's why they complement each other, kaya magiging NaOH. Ang Cl may charge na negative, ang H ay may charge na positive, kaya crisscross, HCl, they complement each other. So this salt, NaCl, is derived from NaOH, which is a strong base, plus HCl, which is a strong acid. That's why ang kanyang salt or ang kanyang aqueous solution of the salt will be neutral. Gets niya na? So parang ganun lang. Will be neutral. Yan. That is the first salt in our experiment. So the second salt in the experiment is we have here sodium acetate, H3O2. So this is sodium acetate. We all know that this salt can dissociate into sodium ion and acetate ion. Yan. Okay? And we all know that this sodium ion came from NaOH and this came from acetic acid. This came from acetic acid or CH3COOH. That came from acetic acid. Okay. So sa mnemonics natin kanina, ang NaOH is a strong acid, strong base, at wala sa strong acid yung ating acetic acid. That's why, ibig sabihin that is a weak acid. This is a weak acid, and this is a weak acid that is a strong base. And we all know that a combination of a strong base plus a weak acid will form a salt that is basic. So, ibig sabihin, this is a basic. So, ang kanya magiging aqueous solution ay magiging basic. Ang aqueous solution niya is magiging basic. So, nagko-coincide ba yun dun sa datas ng experiment? So, maybe, and, tingnan natin kung nagko-coincide sila dun sa datas ng experiment. Okay. So, ito yung datas natin. So, ito, nag-coincide siya, naging basic yung solution niya. So, tama yung analysis natin, I mean. Next is, we have the next salt. Ang next salt natin is, ammonium chloride. So, this ammonium chloride can dissociate into an ammonium ion and chloride ion. Okay? So, and we all know that this came from ammonium hydroxide and this came from hydrochloric acid. In our mnemonics, hydrochloric acid is one of our strong acids, but so this is a strong acid, but ammonium hydroxide is not one of the ammonium hydroxide is not one of the strong bases. So, ibig sabihin, this is a weak base. So, it will form an aqueous solution which is acidic. Following yung sinabi natin kanina na kung sino ang mas stronger sa kanila, yun yung magiging pH ng ating solution. Kasi mag-i-emit siya ng cation coming from the conjugate acid of the weak base. coming from the conjugate acid of the weak base. So nagko-coincide ba 'yon sa ano natin, sa data natin? Yeah. It coincided with the data. Okay. The next salt that we are going to identify is our sodium carbonate. This is sodium carbonate. Na2CO3. Sodium carbonate. So sodium carbonate can dissociate into sodium ion and a carbonate ion. So we all know that this came from NaOH and it came from a bicarbonate. Carbonic acid. Came from a carbonic acid. So NaOH is one of our strong bases. And carbonic acid is not one of our strong acids, so this is a weak acid. So the salt solution will be basic. And yeah, it's base. Basic yung salt solution niya, according to the reading ng pH meter. Okay. Next one is we have here potassium nitrate. Okay? Potassium nitrate can dissociate into potassium ion and a nitrate ion. Okay? And we all know that this cake came from potassium hydroxide and this came from nitric acid. Okay? Diba? So in our mnemonics, potassium hydroxide is one of the stronger bases. So we have here a strong base, and nitric acid is one of the stronger acids or strong acids. So do we have here a strong acid? That's why a combination of a strong acid and a strong acid will form a neutral solution. So this is neutral. So nagko-coincide ba siya sa data natin? Yes, nagko-coincide siya sa data natin. And then the last salt that we are going to discuss is this. So we have here zinc chloride. So it can dissociate into zinc ion and chloride. Okay? This zinc came from zinc hydroxide, and this came from HCl. So HCl is a strong acid. Zinc hydroxide will be a weak base. So ibig sabihin, ang solution natin will be acidic. And it coincided with our shown data here. So there is a very good experiment kasi tumama lahat ng datas natin. Okay, tumama lahat ng datas natin dun sa theory na kung magiging acid ba siya or kung magiging base ba siya. Okay. Yeah. Now, we can identify whether the aqueous solution of the salt can either be acidic or can either be basic, acidic, or neutral, depending on its molecular formula. And then, hindi nyo nararamdaman na ano na natin yung first objective ng experiment, which is to examine a certain salt solution, whether it can be acidic, basic, depending on its or neutral, depending on its molecular formula. And then the second objective there is to measure the pH of the salt solution using an acid-base indicator or the pH meter. So hindi naman siya hindi naman memorize sa inyo yung siguro yung mga pH reading. Pero as you can see in the data, in the table here, lahat ng tinest natin kanina, nag-coincide siya kung either neutral, basic, acidic, or something yung ating mga salt solutions na tinest natin kanina. And then it is also very important to note that the deionized water is also basic, and then the boiled deionized water is also basic. So ang mga acidic lang natin na sample will be the ammonium chloride and then the zinc chloride. The ammonium chloride and zinc chloride. And then the neutral sample will be the sodium chloride and then the potassium nitrate. And all of them are basic. And also, so we use several indicators. So the first indicator is a methyl orange. So in a methyl orange, ang kanyang color change ng pH range niya ay nag-range from orange to yellow. orange to yellow. So this is for acid solution or acidic solution, and this is for alkaline solution or basic solution. Next is we have the methyl red. Sa methyl red naman, ang kanyang color range ay nag-range from red to yellow, acid to base. So ibig sabihin, in a solution that is tested by methyl red turned red, so ibig sabihin that is acid, acidic solution. A solution tested by methyl orange turned yellow, that is a basic solution. Next is we have here bromothymol blue. Ang bromothymol blue naman, ang kanyang color range ay nag-range coming from yellow to blue. This is for acid solution, acidic, and this is for basic. Next is we have phenol red. Ang phenol red naman, nag-range siya from yellow to red. Acidic, basic. Next is we have the phenolphthalein. Phenolphthalein, nag-change siya from colorless to reddish pink. This is for acid and this is for base. And last, we'll have the universal indicator. So sa universal indicator, since it is a combination of several indicators, ang acidic color range na nag-range coming from yellow to red, samantalang ang base niya ay nag-range from violet to blue. So, ito. So, ito siguro yung kailangan nyo lang tandaan. Kasi wala namang data na ganito si ma'am, so hindi naman niya siguro paano kung ano yung mga color changes. Basta, kung alam nyo na for example na NaC, for example na, halimbawa, so we have, for example, sodium carbonate. Diba sodium carbonate is a combination of sodium hydroxide and a carbonic acid. So it is a basic solution. So normally, kung itetest nyo sa bromothymol blue, then magiging blue yung color niya. Pag itetest mo naman siya sa phenol red, then magiging red yung color niya. Parang ganon. So, magiging red yung color niya. So, as you can see here, parang ganito rin din. So, di ba? Tinest mo siya sa bromothymol blue, naging blue yung color. Sa phenol red, naging peach, which is near sa red. Di ba? Okay. Halimbawa is we have the zinc chloride. Zinc chloride is an acidic solution. So, ibig sabihin, pag tinest mo siya sa phenolphthalein, may siyang colorless. Or, pag tinest mo siya sa universal indicator, ang kanya maging range is from acidic to, ang kanya maging range ng color is from yellow to red. So, dito, zinc chloride sa phenolphthalein, white. So, siguro colorless yan. Since sa universal indicator, naging light brown daw. Or light brown down, which is malapit dito. Okay? Malapit dyan. Ano pa ba? Ano pa bang example? For example, we have here ammonium chloride. Ammonium chloride is an acidic solution. So, for example, pag nilagay mo siya sa methyl red, magiging siyang red, or sa methyl orange, magiging siyang orange. Tingnan nga natin. So, we have here, So, we have here, methyl red is magiging siyang yellow daw. Ammonium chloride. Magiging siyang bright yellow. And then sa methyl orange is magiging siyang bright orange, which is nag-coincide natin dito. Bright yellow yan. Pero ganun. So, yon. Kung alam mo kung ano yung magiging, kung either magiging acidic siya, basic siya, or neutral, then mahuhulaan mo na kung ano magiging color dito. Kasi ito lang naman yung magiging color ranges niya. Okay? And syempre, sa pH niya, using pH meter, pag acidic, syempre ang pH niya will be less than 7. Pag neutral, pH niya will be equal to 7. And pag basic, ang pH niya will be greater than 7. Okay. pH niya will be greater than 7. Okay. So the text objective of the experiment is to explain the chemical behavior of salt in water by writing the net ionic equation. So we have several salt. Oh my god, I used permanent marker. I'm done. Okay, so using a net ionic equation. So yung net ionic equation na yon, ibig sabihin nun, that is the reaction or the hydrolysis reaction of each ion, in water. Kasi we all know na, 'di ba, we all know that a salt is an electrolyte. As sinabi kanina, one of the characteristics of an electrolyte is it can form a it can form ion. It can form ion in aqueous solution. And these ions can react with water, and and that is what we call as a hydrolysis reaction. So for example, we have here a table salt, NaCl. So NaCl, it can dissociate into sodium ion and chloride ion. So ang kanya maging net ionic equation in water is Na plus H2O. Na plus H2O is anong maging product niya? It will have no net ionic equation. It will have no net ionic equation. Bakit? Kasi para ma-balance to, dapat mag-form siya ng sodium hydroxide, di ba? Pero hindi kayang i-give up or hindi pwedeng i-give up ni central atom dito si oxygen. So hindi niya kayang i-give up yung oxygen, hindi niya kayang i-give up yung hydrogen or something. So magkakaroon siya ng no net ionic equation. Sa chloride plus H2O, it will also form a no net ionic equation. No net ionic equation din yan. Well, hindi magkakaroon ng, ibig sabihin ng no net ionic equation, hindi siya magkakaroon ng reaction. So, kaya nga naging neutral yung ating salt solution, di ba? Kasi nga, yung ions na to, hindi niya hinhydrolyze yung water. That's why, nagkaroon tayo ng neutral salt solution. Next, we have sodium acetate. Yan, sodium acetate. So it will form into sodium ion and acetate. Sodium ion and acetate. Yan. Okay. So pag kinumbine mo siya sa tubig, sodium ion cannot hydrolyze water. So it will have a no net ionic equation. Acetate ion into water. It can hydrolyze water kasi negative. So ibig sabihin it is base. Basic siya, 'di ba? Basic. And base, according to Bronsted-Lowry, is a proton acceptor. So, pwede siyang mag-accept ng proton coming from water. Kasi ang water is ganyan, di ba? Yan. So, pwede siyang mag-accept ng proton dito. Magiging, yan. Tapos, i-combine niya dito para maging acetic acid. CH3COOH plus OH. So, nag-form siya ng OH. So, ibig sabihin, that is a basic. Kaya nga, ang salt natin na to is a basic salt. Kasi nag-form siya ng OH. Ito yung kanyang net ionic equation ng acetate ion. So, ang net ionic equation ng acetate ion is an acetic acid, CH3COOH plus OH. Yan. So, at it will form a basic solution. Which is, tama ba? Okay. Tama. Which is a basic solution. Next. Okay. Next is we have the ammonium chloride. So NH4, NH4Cl. Okay, ammonium chloride. So it will form an ammonium ion and Cl. So ammonium, when it is, pag inano mo siya sa water, mag-form siya, or ang ammonium ion na to, kaya niyang i-hydrolyze sa tubig. So positive siya, so ibig sabihin it is an acid. Acid according to Bronsted-Lowry is a proton donor. So pwede siyang mag-donate ng proton. Kasi 'di ba, pwede siyang mag-donate ng proton. So pwede siyang mag-donate ng proton dito kay water. It will act as a base. So pwede siyang mag-donate ng proton. Babawasan mo ng isang hydrogen, so mayigi siyang NH3 which is an ammonia plus a hydronium ion. So nag-form siya ng hydronium, so ibig sabihin it is an acid. So Cl, pag kinombine mo naman siya sa tubig, it will have a no net ionic equation. So as you can, kaya nga nakita nyo na ang resulting aqueous solution nito is an acidic solution because of the formation of the hydronium ion in the product side. So tama, ang NH4Cl natin is acidic. That is the net ionic equation. Okay, next, we have here Na. Okay, so we have sodium carbonate. So sodium carbonate, it will dissociate into carbon, into sodium and into a carbonate ion. Okay, so Na plus H2O, it will have a no net ionic equation. Walang magiging reaction sa kanilang dalawa. And CO3, negative 2, plus H2O, may magre-reaction kaya. CO3 plus negative 2 plus H2O. So, dito, okay. So, this is negative 2, so ibig sabihin it is a base, di ba? Base, according to Bronsted-Lowry, is a proton acceptor. So, pwede siyang mag-accept ng proton coming from water. So, pwede siyang mag-accept ng proton coming from water, forming a bicarbonate, and a hydroxide. Kasi nabawasan mo ng isang hydrogen, so naging hydroxide na. Okay, forming a bicarbonate and hydroxide. So, ang magiging resulting aqueous solution yan is magiging basic because of the formation of a hydroxide ion dito. Which is, tama, basic yung solution niya. Next is we have potassium nitrate. Yan. Okay, potassium nitrate. So potassium nitrate, potassium plus H2O, it will have a no net ionic equation. NO3 negative plus H2O, it will also have no net ionic equation, forming a neutral solution. Kasi nga nanggaling silang dalawa sa parehong strong na acid at strong na base. Okay, next, we have zinc chloride. So zinc and chloride. Okay, so zinc chloride 2 plus H2O no net ionic equation. Hindi mo siya magkakaroon ng reaction, pero ito pwedeng magkaroon ng reaction, forming zinc and hydronium ion. Kasi pwede siyang mag-donate ng proton dito. Kaya magkakaroon tayo ng acidic solution because of the formation of the hydronium ion here. So, lahat ng diniscuss kong net ionic equation nag-coincide dun sa acidity, neutrality, or basicity ng bawat salt solution. So, tama yung naging pag-target natin dun sa problem. Okay? So, by that, Alam na natin yung mga net ionic equations ng bawat salt na na-involved dun sa ating experiment. Okay, so let's test. In post-lab, nandito na, sinabi na, what are the guidelines in predicting the acidity, basicity, or neutrality of a salt by examining its molecular formula? So, sinabi ko na nga kanina na by examining its molecular formula, dapat malaman mo kung saan ang galing yung salt na yon. So, whether ba nanggaling yung salt na yon sa combination ng strong acid or sa strong base, nanggaling ba siya sa combination ng strong acid and a weak base, or a weak acid or a strong base. Sa pamamagitan ng tatlong mnemonics na yon or sa tatlong guidelines na yon, malalaman mo na kung whether magiging acidic, basic, or neutral yung magiging salt solution. Halimbawa, sinabi ko kanina, so we have here the NaCl. So NaCl came from NaOH, which is a strong acid, and HCl, which is a strong NaOH, which is a strong base, and HCl, which is a strong acid. That's why ang kanilang magiging solution, ang kanilang magiging pH will be, ang kanilang maging acidity, basicity, or neutrality, whether kung ano sa kanilang dalawa is magiging neutral siya. Kasi nga, it is a combination of a strong acid and a strong base. Samantalang halimbawa, yung NH4Cl. NH4Cl came from NH4OH, which is not NH4OH, which is an ammonium hydroxide, which is not one of the strong bases, and HCl, which is a strong acid. That's why na-dominate yung acid, that's why maging acidic yung solution. So those are the guidelines. Those are the guidelines in knowing the acidity, basicity, or neutrality of a certain salt solution by just examining its molecular formula. Pero sinabi ko nga kanina, if it is a combination of a weak acid and a weak base, mahirap siya. Kasi nga, it will form both an anion and cation that can hydrolyze water. Pero ang magiging pH niya will depend on the strength of the individual ions. Kung sino man yung mas malakas sa kanila. Kung mas malakas yung cation, din magiging acidic. Kung mas malakas yung anion, din magiging basic yung solution. Okay. So, in this number, sa number 2, may ipinadetermine sa atin kung acidic ba siya, basic ba siya, or neutral. So, first one is we have here the sodium hydroxide. So, first one, we have here a sodium nitrate, Sodium nitrate came from sodium hydroxide and a nitric acid. Both are strong acids and bases. So, ibig sabihin that this will be neutral. Okay? Next, we have sodium sulfate. Sodium sulfate came from sodium hydroxide, and we have here a sulfuric acid. Both are strong base and strong compounds. So we have here a strong base and a strong acid. That's why magiging neutral din yung salt solution natin. Okay, next we have ammonium sulfate. Ammonium sulfate, this came from an ammonium hydroxide, and this came from a sulfuric acid. Ammonium hydroxide is a weak base, sulfuric acid is weak base, sulfuric acid is a strong acid. That's why maging acidic yung solution natin. Kasi nag-dominate yung acid. Okay. Next, we have K2SO4. So this is a potassium sulfate. Potassium sulfate came from potassium hydroxide. Sulfate came from sulfuric acid. Strong base, strong acid. So magiging neutral yung solution natin. Next, we have potassium phosphate. Okay? Potassium phosphate. Potassium came from potassium hydroxide, which is a strong base. Came from phosphoric acid. Phosphoric acid, which is a weak acid. So magiging basic yung solution natin. Weak acid, so magiging basic yung solution natin. Okay, next, we have potassium bicarbonate. Potassium bicarbonate, so we have here potassium hydroxide, and it came from a carbonic acid. So this is a strong base, a weak acid, so ang magiging niya will be basic solution. Yun. Alam mo na kung doon na-apply natin doon yung first, na-apply natin doon yung first na objective ng experiment, which is to identify whether a salt solution is acidic or basic or neutral depending on the molecular formula. So the third question is why it is necessary to boil the distilled water in the experiment. So it is necessary daw to boil the distilled water in the experiment because an unboiled distilled water is relatively acidic. So ibig sabihin, pag binoil mo yung distilled water na yon, hindi na siya magiging acidic kasi pag acidic yung distilled water na gagamitin natin, it can somewhat affect the pH of the salts that are being analyzed. So it is necessary to boil the distilled water. So as you can see here nga dito, ang boiled deionized H2O natin is basic at ang deionized H2O natin is also basic. So ano ba ang important tips? Okay, so dito sa procedures natin, hindi naman tayo pinag-prepare ng salt solution kasi nakahanda na yung salt solution natin. Pinag-prepare ba? Hindi ko lang alam. So, sa salt solution na to, so, ang unang ginawa is to identify the mass of the salt that is being needed. So, ang formula lang natin dito is the grams of solute, which is the salt, is equal to molar mass times molarity times the liter of solution. Molar mass times molarity times the liter of solution. For example, calculate the mass of the salt needed to prepare 100 ml of 0.1 molar salt solution. Use 0.1 molar salt solution. So, grams of solute, ang molar weight, for example, ang salt na, for example, na is-prepare natin is NaCl. So, ano ba yung molar weight ng NaCl? Hindi ko alam. So, halimbawa, ang molar weight ng NaCl is, halimbawa, 12. It's just an example. 12 times molarity, given, which is 0.1 molar. And then, the liter of solution is 100 ml, so 0.100 liter. So, multiply that, and that will be your grams of solute para sa preparation ng salt solution. So, nagmula to sa formula ng ating molarity, which is, nagmula tong formula na to sa formula ng molarity, which is, mass of solute over molar weight times the liter of solution. Pag kinuha mo tong mass ng solute dito, so magiging na lang siyang molarity times molar weight times liter of solution, which is pareho nito. So, yeah, that's it for the coverage. Ano pa ba? It's an important note. So, yun. So, that's all. Bye.